Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and is broadcast by Agama Research and Development. So as I indicated, we're going to have a nice lesson on technical science. We have our WhatsApp number, which is 063-629-93655. So I'll repeat the WhatsApp number, 063-629-3655. So that's why you can send all your questions that you are having. We are having this paper to prepare for your paper that you are writing tomorrow. We are focusing on the topic mechanics. We are hoping that you'll be able to collect as many marks as you can. Without any wasting of time, you will remember for the final end of the year, you will still have a paper with 150 marks. Of those 150, mechanics carries 93 marks. So you can see mechanics is a big topic with 62% of the paper, meaning that if you do very well in this topic, you will be able to pass paper 1. So those are the topics. Our questions, as usual, you will have multiple choice questions, which is 20 marks. So you will have that. Then you can have either 8 matching items or 8 one-word items. This comes from the exam guideline. Section B with structured questions or long questions with 122 marks. So we have the total of 150 marks. You will be writing the paper for 3 hours. So that is the mark allocation. Now, the quick wins. Remember, learners, we are saying here, definitions. You have to get these marks. I call them free marks because these are level 1 questions that you just have to recall. So ensure that you go to your exam guideline as you prepare for your papers. Go to exam guideline and learn all the definitions. So you have to be able to recite all the definitions because you'll be, remember, definition carries 2 marks. So we're saying you have 2 marks for every section. If you can check all our previous papers, you will see that they almost always have what? A definition question. So we're saying no for question 2, the definitions, all the questions, you must know all the definitions. And we're saying we use the exam guideline. I hope you have a copy of exam guideline. If you don't have a copy, request one so that you remain with a copy and you are able to prepare yourself well. So in terms of multiple definitions questions, we are saying it's all or nothing, meaning that you must ensure that you say the way you write the way they're supposed to be written. So it's important that you write the correct definitions the way they are written on the exam guideline. We're saying include all the keywords and ensure that when you read the definition, it makes scientific sense. Remember, there must be scientific sense. We don't have to lose the scientific sense when we are dealing with this type of question. So I'm saying to you, ensure that you are able to deal with that, so that we don't have any problem. So we are saying every long question in section B will require you to remember a definition or 2. These are your easy marks. So we're saying collect definitions, and we're saying our Bible, as long as definitions are concerned, is examination guideline. I'm saying now, as you prepare for your exams and your prelim and your final end of the year exam, ensure that you are using the exam guideline for definitions. I hope I've said that and I've emphasized. Even in terms of multiple choice questions, you will be able to find some definitions there. So it's very much important that you know the definitions. So again, we're saying these are the quick wins strategy. We're continuing. We're saying we're putting more emphasis on the definitions and understanding of concept, the importance of a data sheet. Remember, if you look at the data sheet, there are as many definitions as you can get. So we're saying look at the data sheet. Some of these definitions, you just go to the data sheet, you will be able to get help to answer many definitions. So I'll be showing you some of the examples that we're going to use to define using the data sheet. Then we're saying again, when you're using the data sheet, we're saying routine calculations that carry 3 marks. So when you look at the number of marks, it tells you how difficult or the types of steps that you're supposed to take. If it's a routine question, which will require you to be able to take the routine questions will require you to be able to take the formula from the data sheet, and then when you have the formula, you must be able to substitute. So you will have the formula, you substitute, then final answer. Remember, for final answer we are saying that you must write the unit, the SI unit. You must write the unit and direction. So always look for that to say what is the formula that I'm going to use. Then you'll go to the data sheet. Then you'll be able to take the formula. After that, you must be able to substitute. After you substitute, you will write your answer. So what am I saying? I'm saying to you, from the formula, you'll take the formula from the data sheet. You will substitute. You will write the answer. After you write the answer must have correct unit and direction. So we're saying FSAUT. So you have to know that for every question, I must look for the formula. Where do I get it? From the data sheet. Immediately when you get the formula, ensure that you have data collection. It's very much important that you collect all the data. Don't just take information from the statement, already you are plugging it into the formula. No, we are saying read, have a highlighter or something to highlight keywords there. When you are reading, you highlight, you collect data. Immediately when you have data collection, you are able to do what? To substitute. So no substitution without data collection. So we're saying the first thing, you will get the question, you will read the question. After reading the question, you will check what is needed. Then you will go to the data sheet. When you go to the data sheet, you are carrying data collection. Data collection is going to tell you which formula you are going to utilize. So that is very much important. So we're saying is the formula, you substitute, and then you write the answer. Then, if you write the answer and not write the unit, we're going to subtract a mark. So don't lose those marks by not writing the SI unit. So we're saying FSAUT, we're saying formula, substitute, answer, then you write the correct unit. Then if it's a vector, for example, if you are dealing with momentum, you know momentum is a vector has got both magnitude and direction. So if you are dealing with the vector, you will always give us the direction to say in which direction that you are going. So I hope this is what you're going to apply, and you're going to collect as many marks as you can. So if you write the formula and not try to substitute on it, so we're not going to reward you the marks for the formula. So it's very much important that you write the formula, then you dress it. You dress it with what? With substitution of the values there. So we are able to award you the mark for copying the formula from the data sheet. So it's very much important. Without substitution, we don't even look at your formula. So it's important that your formula must be dressed with what? With information that you have collected during your data collection. So look at the number of marks they will tell you. If it's 3 marks, it means you will see that you are going to look for the formula, you substitute, then you got your answer. So that is the FSAUT. I hope you understood that, and we are going to utilize that as you continue with your papers. The other thing which is important is what we refer to as mathematical skills. To say the use of mathematical formula that is provided in the data sheet. Remember, data scientific notation. It's very much important to know the scientific notation and convention of units. You will remember, if you are doing with power, we can give it in horsepower as well. So you must be able to convert those units from one to another. For example, we can give you a question in kilometers per hour. So you know our unit there, we're using meters per second for the speed or for our velocity. So you have to know that if it's kilometers per hour, you have to first convert it to meters per second. So we're saying always remember how to convert from one SI unit to another. Vectors, as I indicated when I talk about FSAUT, I said always make sure that if it's a vector, it must have direction. So if you are writing a vector, it will have direction. And then when you have graphs, because we'll give you some of the questions where you have a graph, for example, a straight line like that, you must know that is a direct proportionality. So you are saying the two on the one on the y-axis and the one on the x-axis, which is your x-axis, your independent variable, and your dependent variable on the y-axis, we are simply saying they are directly proportional. So you have to understand, when you say directly proportional, we're saying when one variable increases, the other one will increase as well. So that is a direct proportionality. So it's very much important to know, to be able to interpret the graph, because there is a lot of information that will give you in the graph form. I hope you got that and you are becoming ready as we prepare. Now, as I indicated, the formula sheet or data sheet, whichever way you want to refer to it. So here we are saying if you are having a data sheet, for example, you will see there it says force. So the good thing about our data sheets, they are even telling you the topic that for this topic you have to run to this particular data sheet. So table number 2 there, you can see. We're having F net equals to MA. You will remember that is Newton's second law. So when you think about Newton's second law, you will think about F net equals to ma. So if you have forgotten, you will always go back to the data sheet to say, I want to remember what is Newton's second law. For example, you see that it starts with F net. So you are simply saying when F net, you can see when F net, so you're just putting a meat on those bones that you see there. So we're saying when F net is applied on an object of mass m, the object will accelerate. You can see already it's like you're copying, because we are saying when F net is applied on an object of mass m, the object will do what? Will accelerate. Immediately after that, because remember, Newton's second law is two parts. So you have to know that it has two parts. You dealt with the first part, which is exactly the way it's shown on that formula sheet. Then you must make the acceleration subject of the formula. So you're saying, you're able to say acceleration is directly proportional to the net force, and acceleration is inversely proportional to the mass. So you are able to get all the 2 marks. Remember I said you must give us all this information. So from data sheet, you are able to state Newton's second law. So it's very much important that you become a friend of this data sheet, because it has information that you need. If I'm to give you another example of how to define using the data sheet, I can say you are having F net delta t there, which is equals to change in momentum. You will know F net delta t, we said, is impulse. So F net delta t is impulse. So when you are defining impulse, you will say, oh, is the product of the net force acting on an object and the time taken when the force is acting on that object. So you will be able to see that, okay, by looking there, you are able to define impulse, because you are saying it's the product. So immediately when you say it's a product, you are saying there's a dot between F net and delta t. We are multiplying F net and delta t. So you will simply say, okay, because we're multiplying 2 variables, it's a product. So you will say it's a product of the net force acting on an object and the time taken when that net force is acting on that object. So you are able to collect your 2 marks. Still, you have used the data sheet to define. Look at, if we say, for example, what is changing momentum, you'll be able to say it's a final momentum, the difference between the final momentum and the initial momentum. If we say define what is momentum, you will go to the formula sheet and see it's mv. Just put that dot between m and v to remind you that it's a product. So you are able to say, oh, I said this in the impulse, I said it's a product. Even here, I'm going to say it's a product. A product between what? A product of mass of an object and its velocity. So we are saying you are able to collect as many marks of definitions using this data sheet. So data sheet, make it your friend and be as close to it as possible, and make sure that you get all these definitions, particularly even those that are in the data sheet. There are some that you won't find in the data sheet, but there are as many that you can use the data sheet to define. And we are saying collect all those 2 marks. We are saying almost all our questions you will find about 2 or 4 marks that comes from definitions, and we are saying collect all the marks. So there's no mark that is a definition mark that you are supposed to lose, because remember, from the beginning of the year you have the exam guideline, you have all the definitions. So we are able to even provide you with a copy of all the definitions in technical science. So we're saying learn all those definitions, collect all those marks, and then be able to go and pass the paper. Then we are all happy. Now, when it comes to multiple choice, remember I talked to the definitions, and I hope I've done justice. I said always refer to the data sheet. It will help you in your definitions. And your definitions, you must write them in accordance to the exam guideline. And you are saying 2 or nothing, all or nothing. So don't give us half of the definitions. You are saying learn the entire definitions and know it. But if you know half of the definitions, it's better to write something than to leave gaps. So we are saying answer all the questions. Don't leave questions answered. Because sometimes it becomes a problem when we say calculate and you leave a blank space. A question that says calculate, immediately it's saying go and fetch the formula, which is freely given in the formula sheet. So don't leave a question that says calculate without an answer. Go and fetch the formula. Make sure that you substitute on that formula, because if you just fetch the formula, you don't substitute, we won't give you the mark for substitution. So I hope I've addressed that, and you understand that for every question that says calculate, you will copy the formula, you will substitute in that particular formula, then you can write your final answer. So I hope we're fine on that. So it's only 2 things I've addressed. It's the issue of formula sheet that you must be able to substitute, and write answer. And when write answer, ensure that you write the units and you write the direction if it's a vector. Number 2, I've spoken to the definitions to say when you are dealing with the definitions, ensure that your definitions is correct in accordance with the exam guideline. And I said refer to the data sheet because some of these definitions are in the data sheet. Now we're going to number 3, the third aspect that I'm talking about of the exam. The techniques that we're giving you, we're saying is multiple choice questions. So when you're dealing with multiple choice questions, we're saying start by carefully reading the question. The learners, they just read something, you see momentum, then already you know what is the answer that you're going to write. No, I'm saying read and understand. Have a pen, have a highlighter, something to highlight the keywords there to say this is what. So we're saying underline the keywords in the question. So ensure that you underline them, those keywords. Most of them you will find that they are in capital letters, so they are capitalized. Some of them they are made bold to show that this one is a keyword, is the one that is leading you to the answer. Decide whether you are required to recall or to use a fact. So some of the questions it will just be a recall, maybe from a definition or from any other knowledge that you are having. And then if you have to use a fact or a phenomenon, or you have to look at the definition, or you have to use the unit or the formula. So always look at those to say what is this multiple choice all about. We're saying first eliminate the answers that are obviously incorrect. I like to refer to that as disruptors. They're just there to disrupt you. So ensure that you get rid of these disruptors. What am I saying? I'm saying we have 4 options that you are given multiple choice questions. Of those, at least 2 are there to disrupt you. Get rid of the 2, then you are increasing your chances. Remember, out of 4, you are having 25% chances of getting the answer correct. But when you are giving you 4, you eliminate 2, you will remain with 2, which is 50-50 chances. Even if you guess, you have 50% chance of getting the correct answer. So that's what we are saying. So always look for the answer that are obviously incorrect, remove them. So we're not saying just go to the correct answer. We're saying no, it's a process. Remember, it's 4 options. And remember multiple choice questions, you are given 2 marks there. So we're saying spend some time there because for every 1 mark, you are allocated about 1.2 minutes. So we're saying spend around 2.4 minutes, 2 minutes spend on that question and ensure that you collect those 2 marks. Don't be in a hurry. Take your time and ensure that you remove the 2 disruptors. You are left with 2 options. Of the 2 options, then you are able to get your correct answer. Finally, we're saying select the correct answer from the others that remain. Remember, you were having 4 options. You got rid of 2. You are remaining with 2. Now you are going to select the correct answer. And this is called elimination, and is particularly helpful when the answer or options are very close to each other. Because some of the answers you'll see, there are 2, but they all look almost like the answer. But there is only 1 correct answer for multiple choice. So you have to make that choice. Don't leave a multiple choice question unanswered. So remember, I said you have 10 questions that are multiple choice. So it's 20 marks that you're supposed to collect. Remember, 20 out of 150. That is a lot of percentage if you look at it that way. So you'll be able to say, no, I have to call. Make sure that as you leave that question 1, that multiple choice question, you have answered all of them. Don't leave that exam room without responding to multiple choice questions. So remember, it's 20 marks. So it's a lot of marks. You ensure, because we do still come across learners who answer those questions, who leave multiple choice questions unanswered. No, commit for something. Say something. Write A, B, C, or C, or D. There must be something next to every letter from 1.1 to 1.10. Answer all the questions. Now, I was saying allocate sufficient card times. I talked to that to say you have 2 minutes at least. Spend 2 minutes in every multiple choice questions because you have 2 marks there so that you're able to collect 2 marks. I hope this will help you as you prepare for your coming exams. Now, let's look at an example of a multiple choice question. It says a fly hits the windscreen. Remember what I said? I said have something to underline with or a highlighter for that case. So you are saying a fly hits the windscreen. A fly, you see a fly, how small it is, of a speeding car. Look at the size of the car. Car is a big car, but it's speeding. This car is a speeding car with a force F. So you know the force exerted by the fly on the car. So that is the first thing that you have seen, is the force exerted by the fly on the car. So you have the car, then there is a force of the fly. The fly exerted force on the car. Which one of the following statement is true? the magnitude of the force exerted by the windscreen on the fly. So you are having on the car, we are looking directly on the windscreen to say it hits the windscreen of the car. Yes. Now the force exerted by the magnitude of the force exerted by the windscreen on the fly. Remember the magnitude. We know the magnitude for the fly. For the fly, the magnitude is F. Now remember what we said. We said you must check whether it's a recall question, whether you have to use a formula, whether you have to use that, so that at least we are able to deal with that. So we're saying ensure that you are able to...
Becoming a successful student is through commitment. Commitment to studying. Commitment to putting in the extra hours in your books. I know it's not going to be easy. Actually, no one said it will be easy. But if you keep pushing, and if you keep believing a little more in yourself, then the results will show in your life. Commit and become.
Thank you. We're still together. We're still dealing with our multiple choice question to say, this is our example. A fly hits the windscreen of the car with a magnitude of force F. So we know the magnitude of the force is F. Now the question is, what will be the force exerted by the windscreen on the fly? So remember, you must ask yourself, is this a principle? Is this a law? Is there any law that we have done that talks to this? When an object exerts a force on another object, what happens? So you will think that, oh, we've done Newton 1, okay, we've done Newton 2, we've done Newton 3. And if you remember, Newton 3 is saying when body A exerts a force on body B. Remember, body A is a fly, is exerting a force on body B, which is in this case is the windscreen of the car. So body A exerts a force on body B. Body B will exert an equal but opposite force on body A. So you already know by reminding yourself that this is a principle, this is a law, it's a Newton's third law for that matter, you will be able to identify the answer. Look at this. You are saying, I said you must remove the disruptors. Remember, the magnitude of the force cannot be determined. You know that is out. So that is a disruptor. The force can either be less, greater, or equal. So now you have a mammoth task of saying out of these three, which one will be correct. And according to Newton's third law, you know that it must be equal to F. So no matter how small is the fly, how big the windscreen of the car is, when body A exerts a force on body B will exert an equal but opposite force on body A. So you are able now to answer and you are able to collect your 2 marks. So that's what we are expecting from you when you are dealing with multiple choice kind of questions. Now, without any wasting of time, let's look at Newton's laws of motion. Remember, we've done 3 Newton's laws of motion and forces. We said we have Newton's first law. So I want us to look at the first law, N1. You can't call it N1, you'll call it Newton's first law. Now, Newton's first law, we are saying a body will remain at rest. So it means you remain stationary. When a body is at rest, its velocity is 0. So a body will remain at rest or in constant velocity. So if it's in constant velocity, you know, constant velocity simply means final velocity and initial velocity are equal. And you know, if you look at acceleration, remember the definition of acceleration? Acceleration is the rate of change in velocity. The rate of change in velocity. So if you look at the definition of acceleration, it tells you it's the rate of change in velocity, which simply says is final velocity minus initial velocity, the rate of change in of velocity. So that is what we are having. So if you say constant velocity, you are saying Vf is equal to Vi. Remember, constant means it remains the same. You are saying the velocity initially and the velocity finally remains the same. So if you say Vf equals to Vi, you are simply saying, oh, the two are equal. And if you have 10 minus 10, definitely it will give you a 0. So when you say constant velocity, you are saying acceleration is equals to 0. So you have to remember that. So when you say at rest, a body will remain at rest. Still you are saying acceleration is 0 because final velocity is 0, initial velocity is 0, then acceleration is 0. So you know that acceleration is 0 at rest or at constant velocity. So when you say constant velocity, you are simply saying acceleration is 0. When you say at rest, you are saying acceleration is 0. So what you are saying is that if you take the F net equals to ma from your formula data sheet, you are able to substitute there that, oh, at rest, acceleration is 0, constant velocity, acceleration is 0, balanced forces, when you say the two forces are balanced, so you are simply saying acceleration is 0. When you have maybe the applied force and the frictional force being balanced, you are saying that acceleration is 0. So under those three circumstances, you know, we are simply saying F net equals to 0. So you have to know that, oh, all the time, when I say, when I'm stating Newton's first law, I'm saying in real sense, F net equals to 0. So the only question you have to ask you, if you want to remind yourself of the definition itself, you will say, when is F net equals to 0? You will say F net equals to 0 at rest, at constant velocity, or when the forces are balanced. So you are able to check, okay, acceleration equals to 0, which is Newton's first law. It means it's those three circumstances. So in a question, when we give you a question and say the forces are balanced, at constant velocity, at rest, so we are simply saying to you, F net equals to 0. So you know from F net equals to ma, you will know that F net equals to 0. So you have to understand that, so that when you are doing your calculations, you know what are you dealing with. Are you dealing with F net equals to ma, which is Newton's second law, or are you dealing with Newton's first law, which is F net equals to 0? So you have to differentiate between the first law and the second law. As I indicated in my introduction, to say, with the first law, we are saying a body will remain, or an object will remain at rest or in constant velocity unless acted upon by an external resultant force. Now, Newton's second law, we are saying, you just look at the formula sheet, data sheet again, as I indicated. So what I'm simply saying, I'm saying for Newton's first law, the data sheet will help you as well. To say, okay, I will go to the data sheet, I will find F net equals to ma. But for Newton's first law, what I have to remember is that a body is remaining at rest or is moving with constant velocity. So if the body is at rest, moving with constant velocity, balance forces, you are saying, oh, F net equals to 0. So for Newton's first law, you will know F net equals to 0. So we're saying a body will remain at rest or in constant velocity unless acted upon by an external resultant force. I hope you got that one as our Newton first law. Now, we're able now to move to Newton's second law, which I said from the data sheet. All you are doing, you are putting when or if, when a net force is applied on an object. Remember, the object has mass, né? Hence we are having the mass there. So when you see M, you can just put a mass stand for the object, because there must be an object that has a mass. So we're saying when a net force is applied on an object of mass M, the object will do what? Will accelerate. So this is acceleration. The object will accelerate in which direction? In the direction of the net force. So don't forget, I usually will put those arrows there to show that acceleration and the net force, the acceleration is in the direction of the net force. So don't forget, we are saying the object will accelerate in the direction of the net force. So that is Newton's second law. It has two parts. Remember, if you say that, your definition is incomplete, because the first part is the F net equals to ma, if I may write here. The first part is F net equals to ma. That is the first part. You say when a net force is applied on an object of mass m, the object will accelerate. Don't forget, it accelerates in the direction of the net force. From there, you make acceleration subject of the formula. So you can just say A equals to F net over m. So this is telling you that acceleration is directly proportional to net force and acceleration is inversely proportional to mass. Then you are able to collect all these 2 marks. So I'm hoping Newton's first law, you will get those 2 marks whenever you find them in the exam, test, any assessment task you are doing. Newton's second law as well, you will definitely get that one. Then we have our friend, which is Newton's third law. You have seen in the last question where we said we have a flag that hits the windscreen of the car. Immediately when it hits the windscreen of the car, we are saying when body A exerts a force on body B, body B will exert an equal but opposite. That's why here I've shown you that when force A exerts a force on body B will exert an equal but opposite, hence the negative there. So the negative there is just to show that the other force applied by the other object is in the opposite direction. So those are the 3 Newton's laws, and we are hoping you are going to enjoy and be able to recite all these definitions and collect your 2 marks, and then you will be happy as you move forward with the topic. Now, you will remember I indicated already on this about Newton's first law, Newton's second law, and Newton's third law. I hope you have understood it, and wherever or whenever you get this question, you would be able to collect the marks in terms of the Newton's laws. Now, problem solving strategy. Now, we're saying in Newton's laws, the following are important. So it's very much important to read the scenario carefully, understand, because you have to decide whether it's Newton 1, Newton 2, or Newton 3 by reading. If a body is at rest, for example, or it's moving with constant velocity, already you are able to see that this must be Newton's first law. But if the body is accelerating, you are able to know that this is now Newton's second law. So you are able to look at that. If there is action-reaction, where a force is applied on an object and the object exerts an opposite force, then you know that that must be Newton 3. So it's important that you check which law is going to be applicable to the question that you are answering. Now, I think identify what the scenarios involve N1, N2, or N3, Newton's first law, Newton's second law, or Newton's third law. Keywords such as rest, as I indicated. At rest, F net equals to 0. Stationary, F net equals to 0. At equilibrium, I talked to the issue of balance forces, F net equals to 0. Accelerate, when the object accelerates, F net is no longer equals to 0 because you now have A. Remember on the formula F net equals to MA, you will now be having A because the object accelerates. It means now, and we said it accelerated in the same direction as that. So you know is F net equals to MA, which is Newton's second law. So I hope you have understood those laws and you will enjoy them as you come across them. If I can continue on that, we are saying when we are dealing with these laws, identify the forces acting on the object. Remember the issue now, we're talking about the free body diagram and the force diagram. So these forces that are acting on an object, you have to identify them to say what are the forces that are doing that. And to do that, we either use the free body diagram or the force diagram. You must be able to underline keywords such as rough surface. Immediately when you say the surface is rough, we are saying to you, you are now going to have friction. So if we say the surface is smooth, we are saying no friction. Rough, friction. So you have to always look at those ways because that's where we are hiding our friction. We hide it on those ways to say it's in a rough surface, it's in a smooth surface. So smooth, no friction. Rough has friction. And then look at the marks. For example, when you're drawing free body diagrams, if it's 4 marks, already we are saying to you, here are the 4 forces that you are going to have. And I will always want to advise you not to rush to resolving the forces. First, draw the free body diagram the way they appear on the diagram that you are given. Then you are able to resolve in order to calculate. But for the collection of marks, because the number of marks, there are no marks for resolving of forces. So I'm saying no need for you to rush into resolving the forces. Draw the free body diagram. Then immediately, before you start with the calculation, resolve. If we will resolve if we have an angle. So you have to understand the issue of resolving. Not all the time. You are looking for the angle. Immediately when you see an angle, you see that you must resolve the forces into the horizontal and the vertical components. We are going to be able to do that, and I hope you will understand it as we move. Now we're saying, as I said, the FSAUT, remember, don't forget, always you will have a formula, you substitute, you write your answer, you write your unit, and then you write the direction. So all the time, all like that. For every question, as you enter exam room, when you leave, for every question that says calculate, you will have done this. Don't leave calculation questions unanswered. The formula is there. Look for it, write the formula, commit by doing data collection, substitute, write the final answer, and then write the units and the direction. If it's a vector, if it's a scalar quantity, no need. For example, if you're talking about mass, you just say 50 kg. You can't say the mass is 50 kg to the north. You see, it can't be. It's a scalar, doesn't have direction. So direction is for vector. So always look at it. When you are writing your answer, check whether it's a vector or a scalar, because you will need direction if it's a vector. If it's a multi-step calculation, you will see immediately receive 4 marks. You will see that it means I'm going to calculate something and come back and calculate something. Then it's going to be multi-step question. So I hope that helps you prepare. Now you must be able to distinguish between the free body and the force diagram. Remember, the force is the normal force and all that. I would always say when you draw the force diagram, when you're learning how to define, it's better to use the force diagram first, because it helps you. Because when you draw the force diagram, you draw force diagram in accordance to the what? To the definition. So if you are saying a normal force is a force exerted by the surface on an object and x perpendicular, it means now when you draw the force diagram, you will say, oh, now is exerted by the surface and is x perpendicular. So you know that, oh, it must be perpendicular to the surface. You know the surface is down here, so you are having the surface there. Then you are able to draw the normal force to say, oh, is perpendicular to the surface. So you are able to draw it. It becomes easier like that to say, oh, okay, when I'm drawing a normal force, because we are saying is exerted, is the force exerted by the surface on an object and is perpendicular. So you are able to do that. So you draw it according to its definition. Remember, our weight, our FG is acting from that center of the object towards downwards. Then you are able to draw FG there going down like that. Then when you talk about friction, remember, friction by definition is exerted by the surface on an object and is parallel. You see the difference between friction and normal force. The normal force is perpendicular, it makes an angle of 90 degrees, whereas the frictional force now will be parallel to the surface. So you are able now to know that it's parallel to the surface. So that will be your friction. So hence I'm saying start by drawing them in the force diagram for your own understanding, because when you're drawing the force diagram, it will remind you of all these definitions to say, okay, let's define these forces. We're having an applied force that is applied on an object. Then you start to say, okay, what is a normal force? You say it's a force exerted by the surface on an object and is perpendicular to the surface. So you're able to draw like that. Then what is frictional force? You will say, okay, frictional force is the force exerted by the surface on an object and is what? It's parallel. So the frictional now is not perpendicular, it's parallel to the surface. Don't forget, the most important key is that you cannot leave out when you are defining friction. It is parallel to the surface and it always, you didn't say or sometimes, you said always opposes motion. So it always opposes motion. So it will be opposing the motion of the object. If the object is going that side, it will go the other way around. Hence it's going back, it's opposing where the applied force is going. I hope you will remember this definition, and when you write them, the definition of the normal force, and then when you draw your FG, when you draw your frictional force, you draw them according to the definition so that you don't forget that. Because immediately you draw that diagram, you will be able to say, okay, it's a normal force. Why? Because it's exerted by the surface on an object and is perpendicular to the surface. Why do we refer to that as frictional force? Oh, friction. Oh, it's parallel to the surface. It's exerted by the surface on an object. It's parallel to the surface and opposes motion. So if you don't say opposes motion when talk about friction, your definition will be incomplete, because it must oppose the motion. So I hope we're able to define those three. Don't forget, when you talk of frictional force, we talk about static friction and kinetic friction. So you have to remember those two, to say static friction and kinetic friction. So you have that. When the object is in motion, so that is kinetic friction for that one. So you have to know that when a force is applied on an object and the object does not move, we say that object, it has static friction. So it means for the object to start to move, you have to overcome the static friction so that we can move from static friction to kinetic friction. So we're saying when a force is applied on an object and the object does not move, it possesses static friction. But when a force is applied on an object and the object moves, it has kinetic friction. So you have to understand that. So I'm not saying when the object is just seated there and no applied force on it, then it possesses static friction. We're saying is when a force is applied on that object and that object does not move. But when the force is applied on the object and the object moves, it has kinetic friction. So those are aspects that are about forces that I thought they are very much important. Remember, when you talk to free body diagrams, you're making a dot. Remember, I've made a box for the force diagram. You saw what I've done there. I've made that small box. Then I indicated the normal force, which is said is perpendicular, the value of forces. And then I indicated if you have applied force, you have Fg, and then you had your friction, which is parallel to the surface. Sorry, you must always look at the size of the friction, because if the object is moving with the applied force, obviously the applied force must be bigger than the frictional force. So always look at that size, because if you find you have a very big frictional force, then we are going to have a problem, because it defeats the purpose. Now, when you're drawing the free body, we are saying you simply now draw a dot that indicates the object. Then you draw your forces, which will be from that dot, your Fg, your applied force, your normal force. They're coming from the same place, and then your friction. So you are able to look at the number of marks. It will always tell you what type of free body diagram or force diagram that you are supposed to draw. Make sure all your arrows touch the dot. You see, like here, giving you a nice example there to say the two don't touch one another, and then we are going to have a problem. Remember, you are drawing free body diagrams on Newton's laws. You are drawing free body diagrams on work, energy, and power. So it's very much important that you collect those marks of free body diagrams in both those questions. Now we're saying always check, make sure all the arrows touch the dot, and always check that you are having the arrowhead. You see now, if there is no arrowhead, there is just a line like that without that which I've shown like that, then it's not a force, because a force must have magnitude and direction. So make sure that they touch. Make sure that there is a line that indicates the magnitude, and we have the arrowhead that indicates the direction that the force is acting. So I hope in terms of free body diagrams, we clarified that as your revision from what you've done in term 1, because now as you are preparing yourself. Now we're saying, if an object is resting on a horizontal surface, so it's just resting, so the normal force will have the same magnitude with the gravitational force. So you will have Fg, you can refer to it as Fg or weight, W, or the normal force, or N. So we accept those. Now we are saying they have equal magnitude and direction. Let's say, for example, this body was a 10 kg body. If this body was a 10 kg body, then obviously you will have a normal force, which is mg, and then which will be 10. You know our g is 9,8. So 9,8. So as you substitute, we always encourage you, don't bother yourself by putting the units to say 10 kg times 9,8 meters per second square. Put the unit with the answer in the final answer. As I indicated, that you will have the formula, the substitution, the answer. So you will be able to indicate that, oh, that is 98. That is 98 newtons. So that positive is showing you now, you will have chosen that downward is positive. Then you know that that is 98. But if you were to look at the normal force, because we said they have equal magnitude, but in different directions. So you have to know that, oh, this one, normal force will be the same, will be 98, but in the opposite direction. So you can choose which one is positive, which one is negative. So you have to know that these two, they have equal magnitude and in different direction. That's why when you are dealing with the issue of FNet, you will see we will ignore the vertical forces there to say the two are equal and in opposite direction, which means if you were to say FNet, you will add 98 minus 98, which will give you 0. So the FNet between those two will be 0. Hence, when we are dealing with our calculations, we'll ensure that we ignore the the vertical forces if the object is moving in the horizontal. We will focus on the horizontal forces, which will be our applied force, our friction. It means our Fnet will have those. So I'm just giving that. So always remember, we can ask you to draw the force diagram, which we start with the box, draw according to the definition. Normal force is perpendicular to the surface, and your weight there from the center of the object. Now, free body diagram, you're just putting a dot. So when you're dealing with free body diagram, when you're just dealing with a free body diagram, you are able to say it's a dot, then you put your objects. I hope we clarified this matter of force diagram and free body diagram. Always, as indicated, look at the number of marks, then you are able to do that. I think I've explained this one, that if the object is moving, we'll have the applied force and the friction, but these two, the normal force, my normal is very far, my normal force and weight there, they will be equal in magnitude. So it's good when you say Fnet, you'll say Fnet equals to F applied plus friction. So you can indicate, friction as being negative because it's in opposite direction. So your Fnet, you will be looking at the horizontal forces because the object is moving in the horizontal direction. The two in the vertical direction, I indicated already that they are equal in magnitude and they are just in opposite direction. So they will cancel one another. So your Fnet, you will be focusing on those two. Even when we are dealing with the issue of work, you will know that the forces that are going to be doing your work there will be the applied force and the frictional force. So we either will say draw force diagram or free body diagram. I want to cover more basics so that at least we do a lot of questions. So I will try to move as fast so that by the end of this session, we have prepared and we have done as many questions as we are supposed to do. If the object is moving, I like this one. If the object is moving horizontal surface with applied force at an angle, you see, already when you have an angle there, it can be anything. It can be beta, it can be 25, whatever, 25 degrees. It's very much important. Remember I said we can only resolve if we have an angle. So in this case, we are given an angle because the applied force is at an angle. So what you are going to do, you will definitely, when you say draw free body diagram, just draw the way they appear to say, okay, we have applied force at an angle, we have the normal force, the FG, the frictional force. Just draw them like that, then it will give you 4 marks. Remember, the number of marks always will tell you what type of questions that we're looking at. Now, you have to ensure that now you resolve. Remember this force, it will be resolved into 2 components, which is Fx and Fy, like that. So when you are drawing, you can't draw the applied force and then you draw the you can't draw the applied force and then you draw the components in the same free body diagram. So if you are drawing like this, you will draw like that. However, the mark for Fx and Fy is still 1 mark because they represent the applied force. Remember, it's the applied force that is saying I'm dividing myself into 2. So hence the mark allocation won't be 5 marks, it will be 4 marks when you are drawing that free body diagram. So I hope you have understood that. And remember, when you have that case, Fx is now F cos theta. So you will use the angle. That's where you're going to use the angle there to say that 25. We use it as in components. F cos theta is the component, which is the horizontal component. So you will use F cos theta, which means this force will be F cos 25 if our angle is 25. And we are saying as well Fy, definitely Fy will be F sin theta. So Fy will be F sin theta. So remember at all times that immediately you see an angle, you will have 2 components. The horizontal component is F cos theta, the vertical component is F sin theta. So I hope that helps you with your revision. So that's what I wanted to focus on when we are dealing with the issue of forces, to say this is what we have to remember. So when you are saying Fnet, you will be able to say Fnet equals to, then you have the Fx and the frictional force. So you have those 2, Fx and frictional force as your Fnet. Remember, I said you can even indicate that your friction is in the opposite direction by putting that minus there. And we'll be able to know that we have the positive force and the negative force. They are in opposite directions. The Fy, remember, under normal circumstances, I said to you, Fg is equals to mg. On a horizontal, we said Fg will be the same with normal force. So there will be the same Fg and normal force. So, but in this case, you have Fn and Fy. So you have to know that, oh, things changes now. Fg now is equals to Fn plus Fy. So you have to remember that to say, okay, immediately at an angle, we're going to have that situation. So you have to know that already. You know that this is F sine theta. And then you know this is mg. So we can ask you here to calculate the normal force. So you just have to substitute the mass, the g, and the f sine theta, which is now your component. How much is the f? How much is the angle? Then you just substitute. Then you are able to calculate Fn. So your Fn will be let me write here. Fn will be equals to mg minus mg, the f sine theta, when it goes that side, it becomes minus. So you have to know that normal force becomes this. So it's no longer equal. Normal force is no longer equal to the mg because of that. So remember that at all times when you say calculate the normal force. Now, with no wasting of time, we are going to linear momentum and impulse. Remember, this is the question that you are expecting to say. The following definitions I must know. Remember, momentum, I indicated, I defined it already. I won't waste your time there to say momentum is the product of mass of an object and its velocity. Where did you get it? From the formula sheet. Data sheet is very much important. And we're saying momentum is a what? It's a vector. Why? Because velocity is a vector. So the velocity nature makes our momentum to be a vector. Which means when you're calculating momentum, you will ensure that you write the SI unit. Remember, mass is measured in kilograms, velocity is in meters per second. So the SI unit for momentum is kilograms meters per second. So you have to remember it's a vector. You must always write magnitude and direction. Then we talk to the issue of Newton's second law. You will remember we said Newton's second law says F net equals to ma. You remember that one. But if you were to substitute now your acceleration, which is change in v, final velocity minus initial velocity over that, then you are able to see that we are having something else. So you are seeing now that, oh, F net would be equals to m times, remember the m, the mass is multiplied by the vf and the vi, you will get mvf minus mvi. So you are able to see that, okay, F net is the rate. The rate means divided by time. F net is the rate of change in momentum. So you are able to see that, okay, F net is the rate of change in momentum. So that is from Newton's second law. So if we say, what is F net? Define F net. You'll say the rate of change in momentum. However, immediately if you cross multiply, you will get F net delta t. F net delta t equals to change in momentum times 1, which is change in momentum. So you can see now we have impulse. Remember, impulse is the product. It's in the data sheet if you are defining impulse. We're saying it's the product of the net force and the time taken when the force is acting on the net force is acting on the object. So that is the definition. However, I'm saying when you define impulse, don't define it in terms of change in momentum. Define it in terms of the product of the net force and the time taken when the net force is acting on that object. So you have to know that to say, okay, when do we say isolated system? We are saying if the system is isolated, we are saying the net force, the net external force acting on that object, on that system is 0. The net external force acting on the object is equals to 0. Net, F net, your external force, the net acting on the what? On the system is equals to 0. So when you say isolated, you are saying there are no external forces acting on this system. So I hope you will remember that. Now we have the principle of conservation of linear momentum. We are saying here the total. Anything that says conservation, you remember to conserve is to remain the same. So we usually will talk about nature conservation. So we're saying don't cut trees, don't do this, because we want the nature to remain the same. So it's the same aspect here. When saying principle of conservation, we're saying of linear momentum, we're saying linear momentum must not change. It must be conserved. So when you define, you'll just put the word total in front of linear momentum. So you'll simply say total linear momentum of an isolated system. Total linear momentum. So the main thing is that it must be of an isolated system. Of an isolated system is what is concept. Of an isolated system is concept. So don't forget that, to remember all the time to say the principle of conservation of linear momentum. You're saying total linear momentum of an isolated system is concept. So if you want everything to remain the same, you must make sure that there is no external forces acting on that system. Because we said when there is no a net force acting on the system, we refer to that as isolated system. So that is for you to remember. Please, you can't go to write any exam or any test or any assessment of technical science, mechanics, and you don't know what is the principle of conservation of linear momentum. Remember, when you indicate the principle, you can indicate it like that, because it's the sum of momentum initial equals the sum of momentum after collision. So you will represent it like that, and then you will be able to address that through the formula. Remember, when there is collision, when the objects collide, they can collide and move together, which we refer to as coupling, or they can collide and move their separate ways. So always look to that to say what is happening after collision. If two objects collide, are they going to move together? Are they going to move in opposite direction? So if they are moving initially, you will be having M1. Obviously, you have the first object, it has its mass and velocity, and the other object as well will have its mass and velocity, and refer to it as initial, because that is the initial. Now, on the other side, it will depend whether they move together or they move separately. So I will advise always, when you're dealing with questions based on the principle of conservation of linear momentum, start by writing the principle like that. We'll give you 1 mark. Remember what I said. When you write the formula, you must make sure that you substitute on that formula so that we can give you the mark for writing the formula. So it's important that you write the principle first, and then you check whether they move together or they move separate. If they move together, you will say it's M1 and M2. They become one. They become a couple, hence I'm saying coupling. So M1 plus M2, and then you are able to do that. So for the visibility, I can write it nicely here to say you will write the principle is the sum of initial momentum and sum of final momentum. We are saying M1 V1 initial plus M2 V2 initial. That must be able to give you now for the final M1 V1 final plus M2 V2 final, if they move separate after collision. But if they move together, your formula will rather be M1 plus M2, because they become a couple, they become one. They will have one final velocity. So this is what is very, very important for you to look at, to say, are they moving together or are they moving separately after collision? Now, what is left is for you to do data collection. When you do data collection, have object A collect data for it. What is the initial velocity? What is the final velocity? What is the mass of body A? Go to the next body, which is body B. In this case, body number 2, you will say what is the mass, what is the initial velocity, what is the final velocity. Immediately when you do data collection, it will even tell you what type of question you are going to be asked. Then you come back here, you derive this formula by substituting. After substitution, write the answer. If you are calculating velocity, remember it's in meters per second. It's a vector, so it must have magnitude and direction. Most of the time, learners lose marks here based on the signs. Remember, if the body A is going to the east, body B is going to the west, they're in opposite direction. You must choose the positive direction to say which of the two is going to be positive, which the other one that is going to be negative. So I'm saying it's very much important for you to choose the positive object velocity, which one is positive, which one is negative, so that you are able to determine the direction. Because you, immediately after calculations, you must be able to commit to say it's to the east, to the west. So you must give us the magnitude and the direction. Lastly, under this topic of momentum, we will look at the issue of elastic and inelastic collision. Now, remember, to do that, you are going to be utilizing the total kinetic energy before. So total, you write that sign for sum, and then you write EK initial. Now, what you have to understand here is that, remember, you're having two bodies. So you will calculate the kinetic, their initial kinetic energy, which is half mv squared initial for the two bodies, body A and for body B. You add them together. Then you calculate the sum of the kinetic energy final of the two bodies to say finally what was their mass. The mass will remain the same. Then you check the velocity that changes after collision, or if it remains the same, you will write it remains the same. Then you calculate the kinetic energy, which is half mv squared for body A final and half mv squared for body B final. You add them together. From there, only from there, you can be able to say this sum of kinetic energy initial is equals to sum of kinetic energy final. If they are equal, you are saying this is an elastic collision. If the two are not equal, you are saying this is inelastic collision. So the question will come to say, tell us, is this elastic or inelastic collision? So your decision will be based on the calculation of the total kinetic energy before and the total kinetic energy after. So immediately when you have done that, you compare them. If from the onset you come and say total kinetic energy initial is equals to total kinetic energy final, already we are losing. The team is losing because you have made a decision to say they are equal already. So you are not starting from a good footing. We are saying calculate the total kinetic energy for initial for both the two bodies, add them together, then calculate the total kinetic energy of A and B, and then add them together final. Then check whether they are equal or not. If they are equal, you will say this is elastic collision. If they are unequal, you will say this is inelastic collision. So that is have to do with momentum. So it's very much important for you to remember that. So the other aspect which is very much important is the issue of changing momentum. Remember, changing momentum we are saying is mvf minus mvi. Yes. So you can even write it as mvf minus vi. So it's very much important to be able to use that one. And then we talk to the issue of third law to say if these two bodies are colliding, body A collide with body B, you can see the issue of third law comes in to say the force applied by this body on this body, it must be the same forces with magnitude but in opposite direction. So when you are using the F net delta T equals to change in momentum, it will tell you to that aspect to say, okay, when you're looking, when you can say calculate the F net, you know that, okay, that is your F net. So you can use body A or body B. It must give you the same answer, same magnitude, but in opposite direction. The other one can be positive, the other one can be negative, depending on the choice that you have made in terms of that one. So if we say calculate impulse, simply saying calculate F net delta T, you can multiply those two, or you can simply calculate change in momentum. So if you calculate change in momentum, you got impulse. If you calculate, you multiply F net and delta T, if you are given the two, still they give you impulse, because impulse is the product of the net force and the time taken when that net force is acting on that object. We talked about this to say these are the tips. Read the scenario carefully and underline the keywords. Remember that the velocity, the momentum, the change in momentum, and the force, they are all vectors. So you are dealing with vectors here. So the issue of direction is very much important. Always take the direction into account, because these are vectors. Refer to the direction when carrying out this calculation, and pay attention to the number of marks. The number of marks will at all times give you that. I indicated to you that elasticity, whether it's elastic or inelastic, I told you already that you will calculate the sum of kinetic energy of the object. If there are three objects, you will calculate the total kinetic energy before, then you compare it to the total kinetic energy after. If they are equal, elastic. If they are not equal, it's an inelastic collision. Now, I think I've talked to all this. I've talked to this as well to say impulse, the product. Remember, it's the product of the net force acting on an object and the time taken when that force acts on the object. I indicated that one. And then with the impulse momentum theorem, we talked as well to the issue of the net force that acting on the object to say you can make net force subject to the formula. Then you will have net force is the rate. So if you say define a net force, it will say it's the rate of change in momentum. So it's very much important. We have done that. Most of the time when you're dealing with this question, you will see we'll give you some time to say you have 2 seconds, you have 0.5 seconds. You know that T. must be multiplied by the F net. Then we get our impulse. So it's very much important that you are able to do that. I'm hoping we are doing well in terms of time, and I'm hoping we are moving together. Now, here's an example on momentum that I wanted us to look at. To say in the diagram below, an air rifle pellet of mass 2 grams. Very much important. 2 grams. Remember, mass is in kilograms. So already you know that you must first do the conversion. Kilo means 1,000. So it means you must divide that 2 by 1,000 in order to get what? To get your kilograms. Is fired into a stationary. Remember I said always underline. Stationary, you know, velocity is 0. The object is not moving. Of clay with mass of 56 grams. So you are having a pellet, 2 grams, 56 grams. All of these, you must convert them. You must convert them by dividing by 1,000 so that they are in kilograms, because we need our units in kilograms. Before it hits the clay, the pellet is traveling at a velocity of 140 meters per second. So you were told that this one. So you know the velocity of this. Remember I said immediately you have 2 bodies. So when you collect data, collect for the pellet and collect for the clay. Collect for the pellet and for the clay, so that you are able to say, okay, what was the mass here? It was 2 grams. You divide it by 1,000. Don't forget. What was the velocity initially here for body 1? Let's call this M1. So that is the velocity was 140 meters per second. Then you go to the clay, you do the same. You collect information to say, okay, it has the mass, body 2 is M2. It has a mass of 56. Don't forget to divide by 1,000 because you are converting it to kilograms. And then you go to, what was the initial velocity for body number 2? V2 initial, it was stationary. So you are able to write that. So you can be able to see that immediately you are able to write, to calculate the momentum, initial momentum of this object by multiplying the m and the v, because we said momentum is the product of mass and velocity of an object. So if you are having the clay as well here, you are able to say, oh, if I calculate, multiply 56 over 1,000, which you will definitely get, then you will get 0. So you know that, oh, the clay was not moving, which means the momentum of that boat is 0. So you are able to calculate momentum initial for both of them. And then on the other side as well, you can look. It says, upon impact, the pellet becomes embedded in the clay. So you can see now our puzzle now is being solved. Immediately when it's embedded, you know that they become one. It's coupling. So remember what I said. The principle, you will say total initial momentum, which means you'll calculate the momentum of the two, you add them together. Initial must be equals the total momentum final. So you will be calculating final. Finally, I said it depends. If they are moving together, it will be M1 plus M2 because they become one. So it's 56 plus 2, which is 58. Don't forget, divided by 1,000 for conversion purposes. And then they will have one velocity. So this side, you have M1, V1 initial plus M2, V2 initial. All you have to do is to substitute and then you get that. But let's go to the question. I was doing that for your understanding of the principle to say, how do we apply the principle? Now, when you look at the question, it says, define an isolated system. I indicated that the Fnet is 0 there in that system. The Fnet of the external force acting on that total external forces acting on that object, on that system, is equals to 0. So we say it's isolated system. It means the Fnet of the external forces acting on that object is 0. And we are saying momentum, you will go to the data sheet, you'll say, okay, it's the product of mass of an object and its velocity. Rather than the magnitude of the initial velocity, you see, the number of marks, it tells you what the type of question to say how long, what is the effort that you must put in. So only 1 mark. So it tells you, write down the magnitude of the initial momentum of the clay. Remember, the clay initial was not moving, velocity, it was stationary here, we were told. So you know that anything times 0 is 0. So you will know that our momentum is 0 kilograms meters per second. Don't forget the unit for momentum is 0. Yes, so in fact the question said write down the magnitude, so it will be 0 kilograms per meters per second. Calculate the magnitude of the momentum of the pellet before initially. So you're just multiplying the mass, which is 2 over 1,000 times 140. Immediately you do that. The 3 marks tells you that it's a formula, it's substitution, and then it's unit. The unit must go with what? With the direction. Remember, you're in the direction of the pellet. So it will be positive in the direction of the pellet. State the principle of conservation of linear momentum. Remember what I said. You just put what? Total. Total linear momentum of an isolated system is conserved. In what? In both magnitude and direction. So it remains the same. The total linear momentum remains the same. Is conserved of an isolated system. So that is the question. I want us to do work, energy, and power, which is our last topic that we will do under this revision program. I'm hoping that you are enjoying, and I'm reminding you all that you have done in term 1, so that when you go to write, you are able to write, collect as many marks as you can. So in terms of work, energy, and power, we are saying you have to know the work done by a force. We have the positive work and the negative work. When do we say the work is positive? When do we say the work is negative? And then the principle of conservation of mechanical energy. This one is very much important. I would like to talk about it here with the interest of time, so that immediately when you get into doing work and power, I've dealt with the issue of mechanical energy. Remember, you have done kinetic energy, which you said is half mv squared. You have done potential energy, gravitational potential energy. The good way to call it is gravitational potential energy, which is now mgh. So we are simply saying mechanical energy is the sum of these two. So when we are saying, when I say mechanical energy, I'm referring to EP plus EK. So that's what you have to remember. Now, when we say the principle of conservation, as we did with the principle of conservation of mechanical energy, you remember we did that. We said the principle, you will put total. So you will say total mechanical energy of an isolated system. Don't forget, it goes with isolated system. Of n, so you'll start from there, you'll say total mechanical energy of an isolated system. Must remain what? The same. Is concept. It's concept. So we're conserving. We want it to remain the same. It must not change. So we're saying the total mechanical energy of an isolated system is conserved. So you are able to collect your 2 marks for saying that. So it's very much important. Remember, you have to remember that kinetic energy, we said, is energy in motion. So the object is in motion, then we say it has kinetic energy. But when the object is at rest, it has potential energy. It's the energy that the object possesses because of its position. So when you add the two energies, energy in motion and the potential energy at rest, when you add the two, you are saying, yes, we have these two, and then we call them mechanical energy. So when you say calculate mechanical energy, we're simply saying add kinetic energy and potential energy. And then when we say total mechanical energy, which is the principle, now remember when we talk about the principle of conservation, we're talking about the sum of mechanical energy initial must be equal to the sum of mechanical energy final. So you have to do that. So you will be having mechanical energy initially and mechanical energy final. So sometimes, most of the time, you will find that we have the object at the top there, maybe it's moving to the bottom there, and all that. So we are simply saying, as we move from the top there, where we had the maximum height, so as we are moving down, your potential energy, because the object was not moving here, we're saying here the top will be now behaving if the object is not moving, you are having your kinetic energy as 0 joules. Don't forget, energy is in joules, but potential energy is maximum there because the height is maximum. If it's 10 meters, it will be 10 meters, then it's moving. Then you will have EP, which is equal to mgh. So it will depend on the mass of the object, can be 10 times 9,8 times the height that we're having. So as the object is moving, the potential energy is being converted to the kinetic energy. You will understand that. But when this principle is saying at any given point, when you add the two, they will always remain the same as long as the system is in an isolated system. So all the potential energy will be converted to the kinetic energy just before the object hits the ground. So I'm hoping you understood that. So when you say use the principle to calculate, you will write the principle as the sum of mechanical energy initial, which is equal to the sum of mechanical energy final. So please collect those marks as much as you can. Now, I want us to do work now. We're at work at this moment. Now, the first thing, this formula, very much important. Work. What is work? Is the product. So we're saying, it's force, ne? Is the product of the applied force on an object and the displacement. So I've applied force there. It's applied force on an object and the displacement in the direction of the force. So remember when we were talking about F net equals to ma, we said when a net force is applied on an object, the object will accelerate in the direction of the net force. Even here, we're saying when you talk about work, force must be applied on an object. So it's the product of the force applied on an object and the displacement. Cos theta, we're saying, is the direction. So this one is very, very much important. It's something that I want to start with and wrap it up here to say. If we are saying work is the product of the force of an object applied on an object and the displacement, and we're saying cos theta is the direction. So you're having cos theta like that. So what are we saying? What we are saying, simply saying here is we're having our force. We're having our force here, which you must identify. Remember, we talked about different forces. It can be applied force, it can be frictional force, it can be normal force, it can be Fg. So the first thing is to draw that free body diagram to know the forces, which forces are doing work. Is this force doing a positive work or negative work, which is what we are doing right now. So immediately when you are having that force delta x cos theta, you are able to say, okay, now this cos theta is the angle, this angle theta, it depends on the relationship between the force. You must understand me here. The relationship between the force and delta x. So if the force and delta x are in the same direction, so it will be, our theta will be 0 degrees. So 0 degrees, same direction, which is cos 0. So it means always you will check two things. Where is the object going and where the force is going? If they're going in the same direction, our theta will be cos theta, it will be cos 0, which means cos theta, cos 0 degrees will be 1. So it will be positive. So which means our work would be F delta x, because it's a positive work that is being done when they are all, the force and delta x are moving in the same direction. Let's look at friction, for example. Remember we said friction, it moves opposite. So it means the object will be moving in one direction and friction will be opposing motion. So when friction is opposing motion, our angle now becomes 180 because it's in opposite direction. You see that? There was no angle when they were going the same direction, but our angle now becomes 180. So you must know that our theta now, it will be for friction, it will be work done by friction. Sorry for that. Let me write here. It will be work done by friction. F, I prefer small f, delta x, cos theta. Now, when you are having that, you are able to say, okay, f delta x. But because the delta x and the friction are in opposite direction, that will be cos 180. And we check cos 180 degrees, that will give you minus. So you will be able to say this will be minus f delta x. The negative work will be done. So you are able to see, okay, when the force and the displacement are in the same direction, is cos 0. When the force and the displacement are in opposite direction, is cos 180. But now we talk about normal force and Fg, which we said are in a horizontal surface. If the force is acting on an object, we said, okay, we'll have normal force. Sorry, that is acting, normal force that is acting in that direction. So the normal force in this case, you will see, I will write work done by the normal force will be normal force delta x cos theta. So always you start by writing the formula. That will give you your normal force now, will give you, you will be able to say, okay, a normal force delta x. But what is the angle? It's 90. Even for Hg, you can use 90 or 270. It's fine. So that is cos 90 degrees. So you can see that cos 90 is 0. So anything multiplied by 0 becomes 0. So the work done by normal force in this case, and the work done by Fg will be 0 joules. Remember, I said when we're doing the forces that if the object is moving in a horizontal surface, we're going to ignore the vertical motion. So in this case, if it's like that, we'll be looking at the two forces that are doing work, because these other two were saying they are doing no work because they are at what? Right angle triangle. They are perpendicular to the surface, so they do no work. So you must know which force does not do work is the forces that are acting perpendicular to the surface. Which forces are doing work? We are saying the forces that the applied force in this case is moving in the same direction with the delta x, the displacement and force same direction, cos 0. So it's positive work that will be done by that one. But now friction is at 180 because the object is moving that side, friction is that, so it will be minus work done. So we have our work net will be concentrating when we're dealing with work net. We'll be concentrating on the two forces. So it's the work done by the two. We simply have to add the two. Remember, net means add. You add the two, they give us a work net. I talked about this to say positive work simply means delta x, and friction same direction. No work done, they are perpendicular. They make an angle of 90 degrees. So no work done. Negative work, we said when they are opposing one another. I hope this slide clarifies it for you. So always know what type of work. Are we going to get positive work, no work done, or negative work that will be done? I hope you are enjoying the lesson. And then we talk to the issue of free body diagram and force diagrams to say identify all the forces that do a positive and negative work. So as you are doing, you must tell us. And even those that do negative work, you must know them. Remember, when you draw free body and force diagram, you include all the forces, even those that are not doing work, which is in this case, it will be Fg and normal force that we talked about. We said you must copy the formula. Immediately when you see the angle, you know you must be able to resolve your forces. So when you see an angle, resolving of forces into components, then you substitute and you write correct thing. Now, remember, in terms of the data sheet, it is given there. So if we're saying define work, you can simply rush there and say, oh, it's the product of the force and the what? And the displacement in the direction. So cos theta is the direction, in the direction of the force. So you're able to do that. When you say what is mechanical energy, you know is the sum total of potential energy and kinetic energy. What is the principle of conservation of mechanical energy? The total mechanical energy of an isolated system is conserved. So everything is there in your formula sheet. You just have to go and fetch what you need and go and utilize it. Now let's look at an example. I will try to be fast so that you remember everything and we cover all that we need to cover. So I'm saying when you say define work, you will go to the formula sheet. You say it's the product of the force and the displacement in the direction of the force. So remember, cos theta indicates the direction of the force. Draw a level force diagram showing all the forces. You see, we'll say show all the forces. After that, we are saying calculate the work done by each force. After that, we're saying calculate the work net. So it means we're saying you calculate the work done by each force, then you add them together. Follow that modus operandi. It makes things easier. You calculate the work done by each force. When you're looking for work net, then you add them together, because some learners get confused when they have to do everything at the same time. So I would advise you to do that. So look at the number of marks there that we're having about 13 marks that you can collect, and with no wasting of your time, I will say that is your solution. So you will write the definition. You will get the 2 marks for writing the definition. For drawing your forces, will give you the 4 marks. It must be there, and then you have your FG there, and then you have your applied force. So you are able to get your 4 marks. Calculate the work done by each force. So you will say, okay, the 2, we said they are in opposite direction, they are equal in magnitude, they are acting in opposite direction. We said no, when you deal with an object that is moving on a horizontal motion, we will ignore the forces acting on the vertical. So you're going to say, okay, the 2 forces of interest is the applied force and the frictional force. So you're able to say, okay, it's work done by applied force. You do that. What was the applied force? It was 20 newtons. And then delta x, the displacement was 10. The force, applied force and delta x, always to determine this, you know they are in the same direction. So that is cos 0. So 200 joules. Don't forget in joules. Good thing about when you calculate your work now or your energy, we are saying it's in joules, and we are saying no, you don't have to worry about the direction. So it's just a scalar. You just give us the direction, the magnitude there to say how much and whether your work is it a positive work or a negative work. So friction, you will remember with our friction, we said friction, the object is going that side, then it's 180. Remember, it's always opposing, so it's cos 180. So you are able to use cos 180. Then you say, oh no, I'm going to get minus 30 joules. So when you get minus equals to the work done by force plus the work done by the frictional force. The two. Remember, the other one is doing a positive work, the other one is doing a negative. Must be positive, the negative must be negative, and you are adding them because a net means you are adding. You're looking for the sum total. So you add them, but the other one is negative, the other one is positive. So it's like friction is taking away from the total work net done. It's taking something out. It's a negative work that is being done. So we'll get 170 joules as our work net. Just look at a question like that one. You are able to collect as many answers as possible. Now, let's look at our last activity for the day. To say now, for this last activity, we are now given a 3 kg block is pulled to the right by a 50 Newton force, applied at an angle of 30 degrees to the horizontal for 10 meters. The surface has a coefficient of kinetic friction of 0.2. The most important thing here, we are saying draw free body. Always check the keywords. Are we saying free body or are we saying force diagram? Calculate the work done by each force. Again, you have to know how to calculate the work done by all the forces. So it's important that you must identify the forces correctly. So it is a free body. You will put a dot there, and then I indicated that as you are drawing the free body, just draw the forces as they look on that diagram. You'll know that, okay, I had the normal force that will be going upward. I had Fg that will be going down, and I have that. And we indicated that the number of marks they will tell you, guide you in terms of how many marks are you going to get. So you will have normal force, Fg, applied force, and your friction. So you collected your 4 marks, calculate the work done. I told you that immediately when you say calculate, you must say, there was an angle. If there is an angle, we must resolve. So we're going to resolve this into the horizontal and the horizontal, which is fx, and then we had the normal there. Then it goes with the fy. So you resolve into 2 fy. Remember, fx we said is f cos theta. Our force was 15 newtons, so you can simply know that this is 15 cos. What is our angle? 30 degrees. So 15 cos 30 degrees. That is the force. This force, the fx. So there are 2 forces. The other one is friction. You're given the kinetic friction. So you have to first remember when you're given the kinetic friction, don't forget kinetic friction, coefficient of kinetic friction, which is this 0.2. So you must have normal force. So it's very much important that now this question, it forces you now to have what? To have a normal force, so that you can know the amount of friction that you are having. So remember, normal force on the horizontal without an angle, we said Fn is equals to Fg. But in this case, we have 2 components. So it means Fg now is equals to, I've indicated this at the beginning of this lesson, to say now Fg would be equals to the 2, which is the normal force, and Fy. So you must be able to say normal force would be equals to mg minus, remember Fy is f sine theta. So all you have to do is to substitute the mass, is the 3 kg there, and the 9.8 minus your force, which is 15 sine 30. So that's all you are doing. Then you are able to get your normal force, so that you can put your normal force there. Then we are able to get our kinetic friction. So I will show you the workouts here so that you understand. So that's what we did. You calculate the work done by the applied force. Remember, we said, okay, those ones. Why do we need normal force now? Because we are given the coefficient of static friction. So that coefficient of static friction, it forces you to utilize the normal force, so that you are able to know how much of the friction that we are having. Remember, we are saying kinetic friction is the coefficient of kinetic friction times normal force. So you have your normal force as 19.4. So you must multiply that by your 0.2, so that you are able now to get your correct answer. So you are able now to add your friction, your work done by your friction. I think we got our friction there as 3,88. You will do the calculations. 3,88, then you take your kinetic friction, you put it there. Our delta x is 10, so it's 10 for delta x. Because friction is at 180, you will use cos 180. So this will give you total work. Remember, work is measured in joules, so just fix that one. So it's work done by friction is minus 38.8 joules. So you are able to add the two, the work done by the applied force plus the work done by friction, to get your work net. So immediately you do that, you are able to get your work net. So this is what I carried here to bring to yourself, to say, as you prepare yourself towards preparations and this test and exam that you will be writing, you will definitely look at this paper, at this section of mechanics, and you will collect as many marks as possible. I hope you understand everything you've done. We started with Newton's laws. We did all the forces, Newton 1, Newton 2, Newton 3. We did momentum, linear momentum, even the conservation of linear momentum. We did our mechanical energy, conservation of mechanical energy. And lastly, we did our work. And I'm hoping you will do a beautiful work and you've understood, and keep on practicing. Practice makes it perfect. And we are saying always look at the exam guideline to be able to get those definitions correct. I would like to thank you. Have a wonderful day.